Welcome to Today in Space. This is our replay of when we went live for the NASA 3I-Atlas image reveal event on November 19th. I share some thoughts in the beginning, and then there is a Q&A with the press at the end. Enjoy, and let me know what you think.
All right, what's going on, everybody? Welcome to Today in Space. Today, we are going to be watching NASA's broadcast since the government shutdown. NASA has not been allowed to release images basically until right now. So now we're going to start seeing the images that NASA was gathering as 3I-Atlas went by its flyby of Mars. So we're so lucky that we have so many things around Mars, but the usual two-day turnaround that these NASA images are supposed to do because they're public domain didn't happen. So what I'm really hoping for with this is that this is going to be something that hopefully there was a lot more time spent on it and they didn't just slap this together after the government shutdown was over. That would be a shame. But I don't think that's what's going to happen, and we're going to find out in 3 minutes and 20 seconds. But from what I can tell, this is a great opportunity for NASA to show a little bit deeper curiosity, a little bit more time with the data before having something released. And the most important thing about this whole 3I-Atlas situation is that we want to capture the public interest of curiosity, and we don't want to bully people out of their own curiosity. There's plenty of fake stuff about 3I-Atlas out there. There's also a lot of people who are taking a scientifically curious route towards looking at the very unique properties of 3I-Atlas, which I'm very excited to have NASA show the data, because that's going to make things a little bit easier. So it's the release of 3I-Atlas images from NASA. Welcome to Today in Space. I'm your podcast host from the East Coast, Alex Giorfanos. Welcome, welcome. We've got people over on YouTube, LinkedIn, Twitch, Facebook, and X. Thank you for joining us. If you're here, let us know in the chat. Also, let me know how the music is. I checked it when we first started. The music and the audio. That'd be great to know. But we're here, people. We've got 1 minute, 49 seconds. We've got the NASA Plus stream. So this is from NASA's website. NASA had a huge overhaul a few years ago with their website. Definitely went the streaming route, the classic, or I guess what we call the classic now, streaming route. So it's called NASA Plus, but it doesn't look like you have to pay for anything. It's provided as part of your U.S. taxpayer contribution to NASA. But I think they've done a pretty decent job with the website. I think there's always more that can be done, but NASA's definitely the I guess what you consider the gold standard of content from space, even though I know companies like Blue Origin and SpaceX in particular are doing a really, really awesome job with their presentation of space, the production of space, and that then is going to make NASA better. You know, it's definitely made NASA update a bunch of cameras that the SpaceX team was doing a really great job of showing stuff off. So anyways, we got 35 seconds. We got Roger Heaps in the chat. Good morning from New Zealand. Good morning, mate. How are you? Good to have you in the chat. It's nice to be live. I am currently recovering from a accidental food allergy from last week, one of which is gluten for me, and went to a place that's usually pretty good, and then they served me a wrap, and for me, it's not a good reaction. So it's been a long, slow week of recovering from this.
To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big, Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view.
But I would just argue, because I can't keep this in anymore, I would argue, if you're saying that it's hard to gather all these images, then the position is not that NASA has a large fleet of devices around the solar system to catch something like that. Those two things don't add up to me.
3 million miles from the spacecraft at that time. And you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche. And these images were the first captured from this perspective. Now, if you think in that lower left you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on.
It's cool. I like that we've got a bit of, I guess it's called the coma, with the tail. It's pretty cool.
Called the Trojan asteroids. Lucy was 240 million miles away from 3I-Atlas, which is circled in the center, when its high-resolution LORRI camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I-Atlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand both the three-dimensional structure of the comet and the nature of the dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3I-Atlas passed within 20 million miles of
this
Mars,
one's interesting,
which gave our Mars spacecraft an opportunity for a close-up. And earlier you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science
wiggles is not what the NASA team should be calling them right now. Oh my God.
Has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I-Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I-Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I-Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I-Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I-Atlas website, go.nasa.gov/3I-Atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. But the answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just
all right,
a reminder
this
to our
is where it's going to get interesting, folks. So they are going to be taking Q&A. I have a lot of feelings about this broadcast, but we'll find out. We've got some press questions. These are usually pretty good.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. Doesn't seem to be a big, or at least we're not seeing signatures.
Oh boy, I don't think this broadcast was a good idea. Because shouldn't they have been getting multiple images over time from wherever they looked that would give them the same resolution?
Into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I-Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from
notes.
some very old population, some solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3I-Atlas is not just
Guys, if you have questions, please leave them in the chat. We'll definitely be talking after this.
Deep past, and so deep in the past that it predates even the formation of our Earth and our Sun.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Phil.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
That's Bill.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft?
Agreed, Roger.
You did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all
this group is going to struggle with this.
That this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got a point. It's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we'd found it. And even, I was interested. I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, we were very quickly able to look for sort of, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for. And so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur. And now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any techno-signatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool.
I'm not answering the question, unfortunately.
Even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not.
I would argue that just like the definition of a planet was changed, Pluto is no longer a planet, our definition of a comet is very basic and doesn't actually tell a good story. And it was instead used as a way to bully curious people into not asking questions. And I'm sad to see that NASA is struggling here, leadership here is struggling to capture that part of this 3I-Atlas event, this cultural moment. So as a science communicator, I'm really not that happy.
Really remarkable and something to be studied in the future. So we're always interested in new ideas. We're always interested.
So
in
he just mentioned the nickel
and all ideas are good
content
when they're born. But those that stand the test
of
of time,
3I-Atlas,
those that stand up to testing, those that are supported by the evidence, are the ones that survive.
But they did not answer if they considered it was an alien craft.
And that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data? And are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that.
This team looks like they are struggling with the politics of this situation.
What we're trying to do always
not even alien related
to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question. And we get little bits, little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects. The way they are distributed through space in the outer solar system show us clues to how the orbits of the major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system. Or in some cases, we point our telescopes at other debris disks, which is just a whole system full of these small bodies. And so now what this will let us do is tell that story in a broader context between the detailed and large library of data we have on those origins of our own solar system, and how volatiles were delivered to make life possible here on Earth, combined with that big picture of other systems, of the dust spread throughout those other solar systems. And now with this visitor that got frozen in time from somewhere beyond our solar system, and that small picture of what that was like when that formed.
And the fact that, I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. It's come into our solar system, our sun. We know,
yes.
we think it hasn't seen a star for a long time. So it's actually
crazier than lottery ticket winning
and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition, and that's allowing us to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged.
So it's like the people talking about 3I-Atlas have never spoken before, right? The people at NASA who are kind of from a, preaching standpoint, hey, it's not, it's just a comet. The people that are asking more questions, like if they just met in the middle, this conversation would go so much further. But it's like they're not talking to anyone who's curious about this.
Atlas, and take a look at the trajectory. I kind of talked through it briefly. Tom talked through it, and you can sort of see where those planets are. And remember this, even though it's exciting and it's coming through, space is huge, as both Sean and Tom talked about. And so the probability of it actually hitting anything is super, super small. You have to have all these things aligned to actually be able to do it. But certainly the objects in our solar system will be just fine.
And we have another question from social media from Astronomeum. They ask, what makes comet 3I-Atlas so different and intriguing compared to the other interstellar comets?
Tom, you want to take that?
The other interstellar objects. We say interstellar objects because not all of them were comets. So the first one was discovered in 2017. That was 1I Oumuamua that behaved very much like an asteroid. Again, a little bit like 3I-Atlas, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive, long-duration observations and understand.
Correction. We didn't have enough spacecraft in our solar system to detect it at the speed it was going through our solar system.
Second object, 2I Borisov, discovered in 2019, behaved, it was a comet. It was definitely a comet. It behaved in a lot of ways like our homegrown solar system comets, in many ways like 3I-Atlas. Its properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3I-Atlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data, we are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also to make sure it's usable, so you can get the tools and things to actually analyze the data as well. And we invite everybody to look at this comet with us. If you're able to take your own images through like citizen science programs, we love that too.
We will try.
We love everybody to be sharing in the joy of NASA science as we take every opportunity to take advantage of these incredible visitors to our solar system.
And that citizen science campaign, that includes work that citizens help us do to identify small bodies in our solar system. And so if you really want to get engaged beyond just looking at the data, you can help us generate new data and find other objects for us to study.
Yep, the big one, our solar, our SOHO, big comet finder, big comet tracker. So many of those comets discovered by our citizen scientists. So keep those observations coming.
All right, we'll head back over to the phone bridge. Our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Go ahead.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual. So that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail early on in the trajectory was part of that, an indication that the dust was being pushed off the sunward side, and then it took a while for the solar radiation pressure.
Why is that not the first thing you talk about, though?
But not very often. I'm sorry, Ken. What was the second part of the question?
Did it?
Helium.
Jets. Yeah. The jets. Right. So seeing more activity are in the inner coma around the nucleus, right around the time of perihelion, when it's being warmed most intensely, is something that happens frequently. That's something the comet observers are going to be very, very excited about. It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with a telescope, but people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P.
Mm-hmm.
It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
Those should have been the very first thing that he brought up on the differences, instead of just trying to put it in the box of comet. Because those are the types of things that for the last month and a half, 2 months, have spiraled out of control on the internet because we're not talking about that up front.
And looking at the details of what other molecules we detect beyond the carbon dioxide and water we mentioned is also going to be interesting, especially for that sort of like, what was this stuff? What was the area in this? What was this stuff made of in the area it was made, like long time ago?
Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations that will be made over the coming weeks as the object comes closer to Earth?
Mm-hmm. I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are blowing off gas, they are blowing off dust, and every time something gets pushed off the comet, that acts like a little rocket engine at that moment and pushes in the other direction.
Like thrust,
and
yes.
So it's very, very common to see comets have subtle changes in their orbits as a result of these little rocket forces.
It's also getting lighter.
Gravitational accelerations. So this is being monitored very closely. I spoke to our orbit determination team of the Jet Propulsion Laboratory earlier this week, and what they said is that this is being monitored. There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
This is definitely difficult as a science communicator to listen to.
look at an object like this. Everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off of 3I-Atlas. Those are the things I'm aware of. There's probably a lot more that I'm not, because like I said, like every astronomer wants to get data on this thing because it's such a rare opportunity.
Yeah, and the high-rise image that you asked about specifically, Amit kind of rolled that out at the beginning. So please take a look at that image. I think Sean is not bragging a lot on what these astrophysics telescope. I don't know why, but because we are able to look at it in infrared with the James Webb Space Telescope, that will be the last time we can see the comet. So as it is exiting the solar system and getting further and further away, the James Webb Space Telescope will actually be able to track it longer than anyone else, partly because of its ability to kind of look long and deep rather than sort of across and wide, and the fact that it looks in the ultraviolet, in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of, tracking it to the very end. Also noted, we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we'd got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then as both Sean and Tom talked about, just really making sure we're sharpening up those images and really, making sure they're calibrated. Right now, we're putting out almost the raw images. We're putting out things quickly so everyone can see them. But we'll take some time and do some, real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that as we move on to do great things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
Want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that. As Nikki said, our desire was to get these images out to the public as quickly as possible. And so there are some image artifacts in there that you'll see, and I can speak to the Lucy image that you saw previously. If you look at the comet, you'll see some blobs around the comet. The little blobs, faint blobs around the comet are not real. It came from the fact that in order to get this particular view, it was necessary, which is this backlit view, the team had to turn the spacecraft to face more toward the sun than it generally does. And so that means some part of the spacecraft were in the sun, and some of that bright, the sunlight reflected off parts of the spacecraft got into the camera, and that resulted in those little blobs. So that's an example of processing that has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the SOHO image where we actually stacked a couple of images because a single image, you wouldn't be able to see it. It would be too faint. But if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3I-Atlas come from so far, moving as fast as it is, and not hit anything?
Orbital dynamics and space is really, really huge. And so, it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1 is now one light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager. And Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from out.
I think my favorite example when I'm talking to people about how empty space is that the distance between Earth and the sun could fit all of our planets in our solar system in between the Earth and the sun, and nothing would touch. I think we need to look back at Carl Sagan and be honest that he was one of the greatest of all time at garnering people's curiosity and interest. And I think as science communicators, myself included, we all have a lot of work to do to compete with the attractiveness of a fake video on the internet. And I think we're kind of stuck in the Stone Age of communicating how awesome this stuff is.
If you squeeze a little bit, and the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question is from Brandon Spector with Live Science.
Hi, I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more? And what will that tell us if it is indeed much, much older than the solar system?
I can start that, but I'm going to pass it to Sean to talk about ages in the galaxy.
Okay.
So cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution and properties, we may be able to get a better handle on what the distribution of ages is.
But we could argue that NASA needs more funding to get more spacecraft and sensors and things in space to check out these things that are coming from other solar systems, which is why leaning into, we don't actually know. Sure, it could be an alien spacecraft, but you know what? We need more sensors. We need more stuff. Like, there is a spin here from a political standpoint. If and this is what this kind of feels like, this meeting. It feels like it just came out of a government shutdown. The leadership politically of NASA are here. We've got an expert. We've got an astronomer. We've got heads of NASA, brilliant people, right? This isn't anything against them. This is a science communication critique, because it doesn't feel like they're talking to the people that are really curious about 3I-Atlas and not just trolling you online. Like, I just think there's so much work to be done from science communicating. That's the long and short of it. We'll go back, but man.
Stars that formed older in our galaxy over time increased their random motions for reasons that Sean will explain. And so that's the circumstantial evidence that makes us think that 3I-Atlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular.
Go for it.
This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like, if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than
That's a great fact.
The amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3I-Atlas what we've seen?
So because we're closer to the grains of sands on Mars, right? And so this is like the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I-Atlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3I-Atlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3I-Atlas, we're still 19 million miles away.
And it's going to...
Which means we need more spacecraft in our solar system.
It's just not... that we just don't have the... If we could, we would. Like, we would be there up close and getting those grains.
All right, well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow along with NASA as we continue to observe 3I-Atlas. Find new images, detailed information, and resources by visiting go.nasa.gov/3I-Atlas and by following NASA Solar System on social media. Thanks for joining.
Okay, all right, give me a sec here. We're gonna reset, but that has been NASA's sharing of the 3I-Atlas data that has been held up since the government shutdown. Now, put myself over here. Okay. Hello. How's it going? So I'm just going to turn off this music from the NASA stream because it sounds like a influencer's vlog. Deborah, hello. All right. So we just closed up the NASA 3I-Atlas conference. Now, before we started this, I was saying how I was really hoping they didn't throw something together here because of the shutdown and that they were pressured to give an answer. And I'm going to be honest, it feels a lot more closer to that than this was what we've seen the great NASA conferences be like, right? Where the curiosity and the attention that 3I-Atlas has been given. I'm sure all of these people are great people. I'm sure that they are brilliant because they wouldn't be there otherwise in some form or fashion. But it felt very preachy, and just like two people who are not talking, who like have very different experiences and are really talking at someone. Maybe it's a fake someone, maybe it's like the way they started that conference off was saying definitively that it is a comet, saying it without saying that, there's a lot of people saying that it is an alien ship or that NASA's holding back stuff. But it also gives off the perspective that you know better than somebody else. And it's something that smart people, intelligent people who try to communicate things, it's something you got to be careful of. That's why the character of Sheldon from Big Bang Theory is so perfect, because he really can't help himself. He's that intelligent, he's that much of a genius, that his personal skills are not great. And this felt like the conference started off as, we are NASA, we are, and I get they're in a tough place politically and they're fighting for their jobs and the existence of NASA, but to sit there at the beginning and say, we know everything we've got, NASA has an insane fleet everywhere across the solar system, but then as more questions get answered, they are admitting, whether they realize it or not, they're admitting that there is a major argument to be said that NASA needs much more spacecraft out than what they have. Not to blame the Oumuamua, the first interstellar object that came through our solar system, to say that it came in too fast for NASA is an admission that NASA actually doesn't have the capability it needs to keep up with what should have been a once-in-a-lifetime opportunity. And that was the major argument that Avi Loeb, the Harvard astrophysicist, who has definitely gone out and had a lot more right hooks with his content about saying this could be an alien spacecraft, Like, it did feel like some of that was targeted towards him. And when you start off at that place as NASA, as the institution, and you say, we know what we're talking about, but then as more people start asking smart questions, that press Q&A, there's some people that are on this press corps asking questions every time. They are sharp, they ask great questions, and unfortunately, and again, not in a bad way, like, it's not like they're going to lose their job over this, but it did expose that it feels like the NASA conversation internally, or the people that were involved in this, didn't have a lot of conversations with people who are just in public curious, like, hey, is this thing actually an alien spacecraft? Is this, like, I just saw this video, like, is this real? And as someone that this is incredible that I've gotten this place after a decade of doing this online, talking about space, that people are trust me enough to message me and ask me, hey, what's going on with this, right? Like, there is a bullying that the intellectual, side of things, whether if you're a nerd, if you've gone to school for science, you've experienced it. There is a intellectual snobbiness that exists. Doesn't matter what organization it is. When there are smart people, there is a snobbiness that comes from it. And there is also a bullying of, even within smart people. I experienced this in school, and it really messed with my brain for a long time. That even at a school where it's all engineers, right? There's no other majors. There's no basket weaving. There's no, like, other stuff, like not even nursing, right? And not that those two are the same, but, like, it was literally just engineers. And even there, where the population of people there are in a much higher category of intelligence for most people, even there, people were considered dumb. I was considered a punk and not smart when I was there, and I succumbed to those not correct ideas. But that is the snobbiness, and there is a level of bullying that is even happening from smart people to simply curious people. Now, do the people who are hardcore on the 3I-Atlas side being alien, or that NASA's lying to us, are a lot of them rude and could definitely ask questions better? Abso-freaking-lutely. But that doesn't mean that smart people need to be rude. And I really do think we all, as science communicators, need to look back at Carl Sagan. We need to look back at, I didn't realize that the music going this whole time. I hope that was good. But we need to look back to Carl Sagan. We need to look back. I mean, we have Neil deGrasse Tyson, right? Science communicators of the past that were so good at capturing people's fascination and giving examples, right? They were constantly working, and it's something I'm trying to work on. Have better examples, talk to more people so that we can have the discussion about, like, that NASA group struggled very hard with, did you even consider this being of alien origin? Which, to me, the most scientific thing you can say to somebody, if you don't have all the information, is not to hold on to the fact that we are a smart place, and if I tell you I don't know, I'm not as powerful, or I'm not NASA anymore. It's about the curiosity. It's about the discovery. It's about that. Like, that's scientific. It's, I don't know. Let's find out. That is scientific. And I'm seeing something that I struggled myself in this group that spoke for NASA today, of probably not having enough conversations with people who are not at NASA about this topic. And they did not consider, they brushed it aside. They did not consider that this could be of alien descent. And that brings me to the other point here, that I think the definition of a comet is too general. And I think we're doing the public wrong, especially when Pluto was reclassified a planet for seemingly good reasons, right? The definition of a planet was too general. We started putting out stuff out in space that was assessing what's out there, and we saw a lot more things than we thought was out there. And even in our own solar system, there were all these other bodies. And so what were you going to do? Are you going to call them a planet? Well, what is a planet? We need to ask deeper questions, because if we use the basic definition of a planet, there's 48 planets. Like that, more data requires further definitions. They even did it with the UAP program. Even at the base level, that the sensors that we have on our most advanced fighter jets are so good that they're picking up things we've never seen before. We even had to have the government reclassify and redefine the word. Maybe there's other reasons for it, but even in that admission, it was, we need to reclassify the definition here, redefine what it is. And I am making the case here that comet is way too general of a term. And I think we really need to have a moment. And Neil deGrasse Tyson made this point without even making the point. He's been a big proponent of Pluto not being a planet, and that it's never going to be a planet anymore. And the next follow-up was, but look how impressive and amazing Pluto is, right? It coincided with the New Horizons mission, and we found out that the Pluto system is like this rare dwarf planet system that is still active, could have jumped off of another solar system and was caught in ours, right? It's very possible that that's where Pluto came from. But the people communicating this are not communicating that part. They're communicating, well, it's not a planet anymore. And I think Neil makes the same point, that if you took the dwarf planet of Pluto and you put it to where it is, where the Earth is to the sun, it would start growing a cometary tail, because the ice would start baking off, being that close to the sun. So does that mean that Pluto is a comet? No, it doesn't. And it means that the definition of a comet is too general and too wide. And so one of the things that I've been talking to people about is there are these things called protoplanets, right? Whether they are like an underdeveloped, like it's a planet that after a star explodes and the solar system is starting to be created as all the dust and the gravity as it's orbiting around the sun, it globs together, forms into like an actual planet. Like that's how these things were formed. The asteroid belts are the areas of that matter that didn't fully come together, right? And there's also this idea of protoplanets, right? Even in the Pluto example, if it did come from another star system, right, and ended up at the very end, or maybe it's just a beautiful conglomeration of the stuff at the third zone of our solar system, like there's some real magic happening there. And a protoplanet, what happened to thought experiments? What happened to deep imagination and curiosity? Because the biggest critique I will have for NASA, because I love NASA, I will always be grateful to NASA for what it's done to inspire curiosity. And even in my time here at Today in Space, like I am so grateful that I've been able to go to NASA social events, to go to NASA to see the inside of the vehicle assembly building, where they assembled the greatest rockets, and the SLS now, right, and Orion. There is a lack of curiosity or about digging into the specifics of questions that people have. This 3I-Atlas is a perfect example that the scientific community needs to up its game in the age of the internet to communicate and offer thought experiments, to dive into, well, let's figure out how to do that. It feels like nobody has time at NASA to do that. And that may be the case. But I just think the approach they took, if the whole purpose of the way that they started that broadcast was to tamper down the 3I-Atlas people who are saying it's not just a comet, and that are hating on NASA, that are going as far as saying it's actually an alien ship, and then those people who are making fake content about it. The way you approach that is going to do the opposite if that was what you were trying to dispel. And then not being ready for those questions, those smart questions that came. They didn't have an answer for the gravitational disturbance. They admitted that they weren't caught up on the data that was going out. Like this meeting, this Atlas, 3I-Atlas event should not, I don't think should have been done this quickly. And I think it was a political event to make sure that NASA is doing its job so that it doesn't lose even more funding. And NASA's just in a really messed up place politically for funding. And I think a lot of this is just the unfortunate, situation that NASA as a government agency has been in after it's been shut down for almost 2 months. And now they're getting together and they've got this thing that was more viral than anything they've done, and they weren't even in session, right? The Chinese released images from Mars before we did, weeks before we did. And, I love NASA. We're going to keep talking about this. We're going to try and get Avi Loeb on the podcast here. We are reaching out to him. But if you guys have anyone else interesting that's curious, that wants to talk about this stuff, I'm certainly up to hear what you guys think. But yeah, we're here. Thank you for joining me. I think I'm going to pop off here pretty soon, unless you guys have any questions. So if you have any questions, let me know in the chat. I would also love to know what you thought of that. I definitely, some of the NASA stuff can feel a little dry sometimes. And the political flair of this meeting was definitely apparent to me. So I had a lot of thoughts, clearly. I was triggered from my college experience. I think that's the thing. The curiosity bullies are the ones that trigger me the most from my time in college. And even just growing up, right? It's two sides of it. It's a complex thing. Being in a place where there's all these smart people, and some of those smart people think I'm dumb. And then being around people I grew up with who are not science people, they wouldn't consider themselves smart people, but those people feeling insecure about their intelligence around me. Like, it's a very weird thing that I've definitely had to figure out over the years. I don't know if I necessarily have it all figured out. There's plenty of times where I will talk myself out of talking about something just because I think, oh, everyone's heard that already, or this and that. So all my critique about NASA here comes from a personal vendetta as someone that wants to be a great science communicator. I think that NASA, where it is at this moment of cultural curiosity with 3I-Atlas, could have done a much better job with that. And I think they're missing the point of the people who are not trolling them about what they wanted to know more about. And I think they could have hit us with the images right away. With, like, I've just seen so many more presentations that were more put together. This felt very rushed. And like I said, very political. So not my favorite thing, but I think it's important to see because it's the thing that's going to help us grow in the future. Yeah. Cheers, Roger. They were not well prepared. That is true. So anyways, folks, that's it. Thank you for joining me and hanging out here in the chat for another Today in Space Live. I'm your host, as always, Alex Giorfanos. Hope you have a great rest of your week. And that's it, folks. Have a good one. Make sure to follow us, subscribe. Talk to you later. Stay curious.